What if buildings could breathe, produce energy, and fight climate change? Welcome to EcoInnovaTech. We're diving into photosynthetic facades, a breakthrough tech that turns buildings into living, energy-producing ecosystems. It's trending with hashtag photosynthetic facades, and we've got 3 global projects to explore. Let's build a greener future, one facade at a time. The buildings are energy hogs. 40% of global energy use and 30% of CO2 emissions come from urban structures, mostly from heating, cooling, and power demands. Photosynthetic facades change that by embedding living microorganisms like algae into building exteriors. These living walls absorb CO2, produce oxygen, and generate bioenergy, optimizing the energy budget of entire cities. Projects are showing how this tech can make buildings sustainable powerhouses. Let's check them out. First, Germany's setting the pace. A project in Munich retrofitted a 10-story office building with photosynthetic facades embedding 500 square meters of algae panels. The algae absorb 2 tons of CO2 daily, producing 1 ton of oxygen, enough for 200 people, and generate 50 kilowatt hours of bioenergy powering the building's lights. That cuts energy use by 15%, saving $20,000 yearly, and reduces emissions by 700 tons of CO2 annually. The facade also lowers indoor temperatures by 5 degrees Celsius, slashing cooling costs. Social media's buzzing. Greenbuild.de posted, "Munich's buildings are alive." Germany plans to outfit 50 buildings with this technology, potentially cutting 35,000 tons of CO2 annually. Next, Singapore's pushing boundaries. A pilot on a residential tower used 300 square meters of cyanobacteria facades, absorbing 1.5 tons of CO2 daily and producing 40 kilowatt hours of bioenergy, enough for the tower's common areas. The system generates 0.8 tons of oxygen daily, improving air quality for 1,000 residents, and cuts energy costs by 20%, saving $15,000 yearly. The facade's biomass is harvested monthly, turned into biofuel, creating a revenue stream of $5,000 annually. At Singapore tweeted, "Living walls for a living city." Singapore aims to scale to 30 towers, potentially reducing 20,000 tons of CO2 each year while powering urban spaces. Now let's head to Australia, where a project in Melbourne greened a commercial building with 400 square meters of algae facades. The system absorbs 1.8 tons of CO2 daily, produces 0.9 tons of oxygen, and generates 45 kilowatt hours of bioenergy, covering 10% of the building's energy needs. That saves $18,000 yearly and cuts emissions by 600 tons of CO2. The facade also acts as insulation, reducing cooling energy by 25% in Melbourne's hot climate. Social media users are calling it a building that breathes. Melbourne plans to expand to 20 buildings, potentially offsetting 12,000 tons of CO2 annually while improving urban air quality. How do photosynthetic facades work? Thin panels filled with algae or cyanobacteria are integrated into building exteriors using sunlight to photosynthesize. They absorb CO2, produce oxygen, and generate biomass that's harvested for bioenergy, typically 100 kilowatt hours per 1,000 square meters daily. The panels are connected to a microgrid, feeding energy directly into the building, and their natural insulation cuts cooling needs by up to 30%. Advances in microbial efficiency and panel durability have made it practical, with costs at $500 per square meter, down significantly in recent years. There are challenges, though. Installation costs $250,000 for a mid-sized building, a hefty upfront investment. Algae need regular maintenance, $10,000 yearly, to prevent clogs, and cold climates can slow photosynthesis by 15%, requiring heating systems. But the benefits are clear. Each ton of CO2 absorbed saves 0.3 tons of emissions from energy production, and buildings save 20% on energy bills. Experts predict that photosynthetic facades could cover 10% of urban buildings, cutting 200 million tons of CO2 yearly while producing energy for 50 million homes. What's the future of photosynthetic facades? Could they turn every building into a living, breathing power plant, balancing urban energy budgets for good? Imagine a city where walls fight climate change. Poll should photosynthetic facades focus on residential or commercial buildings first? Drop your ideas in the comments and join the living building revolution. Photosynthetic facades are proving architecture can be sustainable. Subscribe for more #EcoTech 2025 videos and check our previous feature on nanoforests for another eco breakthrough. Thanks for watching. Let's grow a greener future, one living wall at a time.